This is a great ideal gas law question. We have 5.7 moles of gas at a pressure of 0.18 atmospheres and a temperature of 46 degrees C. What is the volume of the container that the gas is in? So the key to answering this question properly is understanding that all of these values are related. And they're related through the ideal gas law, which is right here. I've written it as PV equals nRT, which is pressure times volume equals moles of gas times the gas constant R, we'll get to that in a second, times temperature. And that temperature is in Kelvin, which we'll convert to in a second as well. So this whole question boils down to this equation and understanding its relationships and figuring out what we're looking for. So we know that we're looking for volume. So the first thing I'm going to do is actually restructure this equation to have it solve just for volume. And to do that, we have volume equals number of moles of gas times the gas constant times the temperature divided by pressure. So I just divided both sides by pressure, moved that over so we can solve for volume. Now when we plug in all of these numbers, we should be able to just pop out what the volume is. So let's start doing that. First, we need to convert our temperature from 46 degrees C into Kelvin. So to convert Celsius to Kelvin, we just need to add on 273.15. So we're going to go to 273.15 plus 46 gives us, let's look at that, 0.15, 91, throw that one up there, so it's 319.15 Kelvin. Then we've got R, and so this is gas constant R. I've grabbed this one. It's 0.082 liter atmospheres per mole Kelvin. And this is a crazy number that you don't have to know, you don't have to remember it unless your teacher specifically tells you to. This number's a little bit crazy. But the reason why I picked this one, because there are a lot of values for it, is because it has everything we need. It's got liters, which is volume, atmospheres, which is the pressure that we're in, and degrees Kelvin. You can find different gas constants with different parameters there, different units, but we're going to stick with this one because it matches what we're looking for, and I just looked it up just like you can do anytime you need to. So this is gas constant R. So now we have temperature, we have gas constant, we have number of moles, and we have pressure, and that's everything we need to plug in to solve for volume. So let's go ahead and do that. We've got V equals 5.7 times 0.082 times 319.15, all divided by our pressure, which is 0.18. And then from here, it's just plug into a calculator to solve. So let me do that real quick. I've got 5.7 times 0.082 times 319 times 0.15. So the top gives me 149.17 equals 149.17 divided by 0.18. Just need to do that last bit of math. 149.17 divided by 0.18. We end up with 828.7 equals 828.7. And I know my unit is liters because that's what I have in my gas constant here. So 828.7 liters, a large amount of gas. And then we need to just check and verify, is this a reasonable answer? So I know multiplying 5 times 319 gives me a really big number, not surprising. Then multiplying it by 0.082, which is like basically 0.1. So it's going to trim that number down. And then dividing by 0.2, which is going to make the number way bigger. So we end up with a pretty big number. And that seems like a reasonable answer based on the math that we just did. So last check is, do we have the right number of significant figures? It looks like 2 is what we have everywhere in the equation. So we just need to round this guy off to 2 sig figs. So that's going to give us 830 liters to finish. Some teachers care about that, some teachers don't, just depends. But that's our answer.